In this problem, we are given that a uniform rod of mass 3m and length L is hanging from a hinge H as shown. And a small ball of mass small m is moving horizontally with a speed u, strikes the end of this rod, say it hits over here elastically. We are required to find the speed of ball and angular speed of rod just after collision. Say after collision, the ball will move with the speed v and the rod starts its rotational motion about hinge at angular speed omega. And we are required to find v and omega after collision. So in this equation, we can directly state, as no external torque is there, we can conserve angular momentum about hinge h. So we can write by conservation of angular momentum about h. We use the initial angular momentum was mul, and after collision the angular momentum of ball will be mvl plus the angular momentum of rod, that is I omega. As the mass of rod is 3m, we can write it its moment of inertia to be 1 by 3m L square into omega. So this will get. Now in this situation, if we just analyze the situation, here this m and m gets cancelled out, 3 also gets cancelled out. We can write it again as u is equals to this L will also gets cancelled out, u is equals to v plus L omega. This is the relation we are going to get by conservation of angular momentum. Now in this situation, if we use the concept of elastic collision, we know well that in elastic collision E is equals to 1, which is the coefficient of restitution, that is equals to separation speed upon approach speed. Here we can write that approach speed before collision of the two objects is u and the separation speed after collision is, the ball was moving at v and the rod is moving forward at this point with the L omega. So here we can write by E equals to 1, we can write approach speed is u and the separation speed we can write it as L omega minus v. From here these equations 1 and 2 we can easily solve and get the value of v and omega. If we add the two equations, you can see we get 2u is equals to 2L omega. That means we'll be getting omega as u by L. And in this equation, if we substitute the value of omega in any equation, then from equation 1 we can state we are getting u is equals to v plus u, and this gives us v is equals to 0. That means we can say after collision the ball will come to rest and the rod will move with the angular speed omega given by u by L. So both of these results, the angular speed after collision and the linear speed of ball after collision, are our answers.